All right, kids, we're going to get into some very introductory geometry here. I'm going to go kind of quickly, talking about, well, the title of the sheet might give this away. So if you notice this crossword here from the New York Times is symmetrical. In other words, if you spun it 180 degrees, turn it upside down, you would have the same exact picture. And I've been told that a true crossword is supposed to be symmetrical in that manner. I don't know if that's really true or not, but that's something called, well, there's a bunch of different types of symmetry. You see them all listed here on the left. 1, 2, 3, there's 6 different ones, right? Horizontal symmetry, obviously the stop sign has horizontal symmetry. We could draw a horizontal line, roughly like that, and then the stop sign would fold over until itself, okay? That's what it means by horizontal symmetry. It has vertical symmetry as well. If you folded it over this thing, it would match up to itself, all right? So it has both those. It also has oblique. Oblique means at an angle, so not horizontal or vertical. Just, can you draw a line on an angle and create symmetry? And the answer for the stop sign, again, is yes. If you were to draw one like that, you could fold it over. So this thing has all kinds of symmetry. Rotational, certainly it does. Rotational, so if you rotated this thing, you would create the same image that you had before. Now, usually what you do here is you give the smallest number of degrees that this thing is rotational by. In other words, the fewest number of degrees you could rotate this and it still match up would be 45 degrees. This is a regular octagon. We'll talk more about that later in the year. And if you take 360 degrees and divide it by these 8 vertices, you realize that these are all 45 degrees away, okay? This also has 90-degree rotational symmetry, but you want to, if you have rotational, you list the smallest number of degrees that are available. If the only rotational symmetry that exists is 360, we don't even say it as rotational then, okay? So rotational is something other than 360, but you list the smallest one possible, all right? Now, this has point symmetry as well, because point symmetry is same as rotational symmetry of 180 degrees. So point symmetry and rotational symmetry of 180 are the same thing. If you spun this stop sign 180 degrees, it would look exactly the same. That's also considered point symmetrical. That crossword up top, point symmetrical. If you rotate it 180 degrees, you get the same thing. Translational, the best thing I'm going to say is look at some examples in the book of translational symmetry. It's like taking the same image and then kind of like stamping it out, time and time and time again. We're not going to be dealing much with translational symmetry, but you can check that out in the book. I'm going to go kind of quickly on this, and don't hesitate to look at the book for some more information as well. So to make it a real crossword means point symmetrical. Okay. So fill in the fewest squares to make this a real crossword. Well, that means I have to be able to spin it 180 degrees. So these two that are colored in, they would have to be colored in down here. This one would correlate to this. Okay. You just have to think about this a little bit. You see this one here? That would be right, where would that be? That would be right here. Right? You see how you have that big square? You have that big square. You put it right on there. It was below there. It's on top. And then, you know, these two, you see how there's this connects to this one? That means it would connect here, and it would be these two. So that would be point symmetrical. All right. Again, you can stop and do this yourself. You know, this one's asking if the crossword designer, blah, 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 fill in the correct squares. Again, it should be fill in the fewest correct squares necessary. So if we were going to be symmetrical around this line here for this one, and it's this line here for that one, you know, where am I going to color in? Well, you can just flip it over the line. You see how this little triangle, that's already accounted for right there, so that's good. This one, if you flipped it over, it would be right here. This one, if you flipped it over this black line, it would be here. Okay. This one, boom, 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 it would be over here. I'm hoping this is making sense. And then this thing here would end up be right there. You see how we're one away. If I go to the, I have one blank one, so there's the blank one, and that's where the blue one would be. So here, flip it over. That you'd leave this, you would be right here. Okay. Obviously, this thing here would flip to this. This would flip to that, and then you'd end up coloring these as well. Think about it. Okay, is it possible for a crossword puzzle to have 90-degree rotational symmetry? That means it has to have point symmetry and 90-degree rotational symmetry. If so, draw one. Think about it. The answer is yes, and there's actually an infinite number of correct answers. You know, like something like this, for example. If I color in these four corner pieces, you know, that has both point symmetry and 90-degree rotational symmetry. Maybe it's not an infinite number of correct answers, but here is another one, right? If I make this X shape, that would be point symmetrical and 90-degree. This interactive in your book, it's actually, this is wrong. It's actually interactive 1.1b. You can change the degree measure of rotational symmetry. Some degree measures show the same symmetry, but not all the ones that you might expect. You should mess with this yourself and make sure you understand it using your iBook. Why is 90 degrees the same as 270, but not 180? Because you see, if you're rotating 180, you're just kind of rotating between the top and the bottom, the top and the bottom, top and the bottom. Okay. Whereas 90, you cover more spots. You got the top, you got the right, you got the bottom, you got the left. And the bottom line is, why are these the same? Is because these are the same number of degrees from 360. So this one's 90 before 360. This is 90 after. And because of that, they're going to cover the same pattern. You know, before checking, is 60 going to be the same as 120? Why or why not? It's not, because not the same number of degrees from 360 or 0. See, 120 is going to cover fewer spots. 60, what would that be the same as? That would be the same as 300, because 60 degrees away from 0, and that would be in each direction. So 60 from 360, you have one direction and versus the other. Play around with it. Should make sense. I'm going to stop the share in this video. I'm going to do a quick one with the section 1.2. Okay.